Hello there, welcome, and this time around we're going to take a look at transaction script, the architectural pattern. So I stole a quote first from Martin Fowler's book. He has a book about all kinds of patterns of enterprise application architecture, and he also describes the transaction script as a way to organize business logic by procedures, where each procedure handles a single request from the presentation. Now this might be a bit vague, and he does include an example in the book and sort of have a small offhand comment about how to expand upon that. So we're not actually doing what he shows, but we'll do the offhand comment approach. So the book is from 2003, and that means this pattern, the transaction script, has been around for a while. It might still be, it is still viable, so that's why we take a look at it here. It's a first simple step to improve the organization of your code on the server or whatever system you're building, but in the business logic layer. So we have our classic three-layered architecture. There's some network responsible for receiving incoming requests from whatever client you have. Then you have the business logic layer or model manager. See, I just call them models here. Sometimes it's model manager. And then we have the data access layer, where we're going to apply the data access object pattern as we saw in the previous video, which talks to the database. So transaction script belongs here. That's what we're going to do. And as mentioned in the previous slide, Martin Fowler, he does a simplified version. That's the example that he has, where he basically collapses these two into one. So the class here will work with result set and save some data back again. And then there's that comment about splitting into layers. So that's what we're doing. This is also the examples I find online. They usually have some kind of data access abstraction. All right, so the purpose, as mentioned, we organize use case scenarios. Maybe that's just update title of task, or change password, or update estimate of task, or add subtask. Right? These are small scenarios, and we want to do them in single procedures, meaning methods. And then we may group coherent procedures or methods into a class, which I call a service. So you might have a task service, and all stuff you can do with a task is managed by the task service in separate methods. So we don't have update task anymore. Instead, we have, for example, a method called update title, and we have all kinds of other methods for each stuff that we can do. We can update the description and update remaining estimate, and we can complete a task. Instead of setting the status, which might also be an option, so you can just update the status, whether it's not started, in progress, finished, whatever. But if you have methods that are specific for that, it's more clear what they're supposed to do. We can add subtasks, we can set assignees, and we can create new ones and delete existing ones. So rather than just update, which would cover most of these methods, the top 6 and more that I left out, you can probably do more. We're going to have these specific ones, so every small thing you can do is handled by a specific method. And that might mean your task service will have a large interface of many different things you can do, but it is more separated, making it easier to work on. So I consider each of these a use case or a scenario. That those two are sometimes mingled a bit. You say one thing and mean the other, but all my books generally call these use cases. So that's probably what I unconsciously is going to do as well. Right, so we move from an interface that looks like this: create, update, delete, get, or find, or fetch, or load, or whatever, which I showed in the first video. And this is a bit vague. What does update mean? We talked about that. And then we want to move over to an interface that looks more like this. We update a description. I add more details over here. Obviously you need arguments and return types and stuff like that, but just to elaborate on the point, we update its description of this specific task with this specific string. We can update remaining estimate, again, specific task, and the new estimate. You can complete a task, given the ID. You can add a subtask with to this task, and maybe you provide a subtask instance, or maybe you provide some other arguments. You can set assignee and so on. Right. So the old simple CRUD interface is swapped out for we probably still have create, delete, maybe get, but the update is at least split out. So that's also what you're going to do most. You're going to modify existing data in most systems. You don't just create a bunch of stuff and then leave it as is. All right. How does this work? What does it look like? Well, we are going to take one approach. There are different approaches, but we will take this one. We create a service class with a star, right? So any kind of domain object you have, service. So you have a task service, which is responsible for managing tasks and doing whatever needs to be done to tasks. You have a user service, which can manage users and so on. Then we're going to have interfaces for each of them. So task service interface and task service implementation. Now, if you want to take this further, sometimes you can create a class per use case. So you have a class that only handles update remaining estimate, for example. But maybe that's a bit elaborate to create so many classes initially. So I suggest you start here, and then you can see how that works out for you. And then we create a method per use case scenario, as mentioned. And most of these methods, so because this is a pattern, there's going to be some repetitions and things that are similar. So for example, we're going to have these services, and most of the methods inside the services, any kind of method that modifies data, is going to have the same structure. So more or less 3 steps. You load the existing data model class from the data access object. So you would load a task. Then you modify the data. And this is where you apply your business logic. So you check whatever rules and do validation and so on. So before you set a negative estimate, you check, is it a negative estimate? In which case you would throw some kind of domain exception saying this is not allowed. And then you save your model class back to the database by using the data access object. So in this case, save might be update or create. You could have one method. Sometimes that's called upsert, because we combine update and insert. Or maybe you just have a update method, whatever you need. But you can combine the create and create and update into one method called save. It doesn't matter. So that's for modifying existing data. If you want to create something, well, we don't load existing stuff. We create a new object. You do whatever rules needs to be checked. Maybe you do that before and then you save it. In case of delete, maybe you need to load it first and then check that there's no data on it that would cause it to not be allowed to be deleted. Can you delete a task which is not completed, perhaps? Or, I don't know, maybe there's a rule. But again, mostly we modify data, and that's going to be this: load, modify, save. So what does it look like? Well, we have this system. From the previous video, we have the data access objects, more of them than what I show here, but that's just a snippet. And then we have a layer with all the services where we are about to apply the transaction script, and then whatever network we have up here, which we don't care about in this video series. That's the plan, at least. Maybe I will elaborate later on. So this one here, we're going to have a class, task service. So this manages tasks. That's the interface. You can update the description and title, I didn't put that in. You can update the remaining estimate, you can complete a task, you can add a subtask, you can set a new assignee, and so on. And that's implemented in a specific class, and it uses the task data access object. Now maybe it also, because you do have something like subtask here, so maybe it needs another data access object. That's okay. Sometimes we have to do that. So business logic layer with our services with specific methods, and we actually use some domain language rather than just update. Now we can complete a task, we can update the estimate, we can update description. This is language from the domain, so it's more clear what's going on. And each method has a very precise responsibility, making the logic easier to implement because we don't have to sort of cover every possible case. And it's separated so it's easier to work in parallel. One person can do the set assignee and another person can do the update estimate. Because it's two different methods, usually Git can figure out to merge this without problems. So this is the idea. And we'll be doing some implementation pretty soon. First, the benefit. We have more specific, precise logic isolated around a single use case scenario, so that makes it simpler. We have cleaner separations between these methods, and we use the domain language. It's easy to work in parallel because you don't have multiple members modifying this update method for two different things. And because that update method does everything, we talked about that, then all the use cases go through it more or less. We are more focused on single responsibility. We have services per domain object and methods per thing we can do with it. So that also means it's easier to identify the location of bugs. If I have some kind of failure when I try to update the estimate and I just have the update method, then it might be difficult to figure out what in the bundled up logic is actually failing. Maybe it's not even related to the estimate. Maybe it's something else that fails by coincidence. But that's split out. It's easier to modify a single use case scenario without interfering with others. So if I need to modify how estimates are managed, what rules there are, maybe initially you can just put whatever positive estimate you want, but then later on, because it's seems to be sometimes common practice to use a Fibonacci sequence, so you want to do that for the estimates. So only certain estimates are valid, then you just have to update that single method. You don't have to potentially break all kinds of other stuff. We have the improved simplicity because each method really does just that one thing. It's a template approach with this load, modify, save, so it's easier to figure out what other methods do even though you haven't written them, and you have a pretty clear idea of what the methods should look like. I feel like I mentioned this, but every new use case is a new method, so it's independent of previous stuff. You don't go and modify the update method all over. Or maybe you another use case adds complexity to when a task is allowed to be deleted, but that should be something else. And we can implement this with test-driven development. So now we actually have something to test, which is going to make it easier for you guys to make unit tests of your system and show examples of that in your semester projects. So that's neat. This is the approach that we're going to do. Now there are some drawbacks. It is quite simple, but that means complex business logic can become difficult. If you need to execute some business logic which consists of using multiple domain objects, so if you have to load a project and task and subtask, different things, then this can become complicated. And there's a risk of duplicating code between the different use case scenarios. When I create a user I need to validate username and password. When I update the password, I need to validate the password. So those rules are the same. And obviously there are ways to refactor your code so you can reuse the same code and keep it dry. Don't repeat yourself. But you just have to be aware that you might be duplicating some code. Okay, but this is the benefit. We can implement it with test-driven development, and that's what we are going to do when we get to the implementation in a short while. Right, how do we do this? Well, the business logic layer is the heart of the system. This is where you have all your logic, all the business stuff. This is where you solve the problem. So this is a pretty central piece of your system. And with test-driven development, we write the test cases first, and we use them to implement the business logic layer, meaning our transaction script procedures, methods. So we're going to use the prescribed approach of TDD, meaning red. That's the initial step. You write a failing unit test. So it's failing because we haven't implemented anything of our business logic layer, or we haven't implemented the stuff that we are about to test because we write the test first. Then we write enough code to make the test pass, so now it's green. And then we refactor our code as needed. So for example, I mentioned that if you create a user and you update the password of a user, there might be some overlap in that, or maybe you have still within one use case scenario, maybe you have some code that needs to be refactored. So then for every refactor of your code, you still run your test and verify that it's still green. Then you go back and write a new unit test that tests something else regarding your use case scenario, and you write code to make it pass, and then you do the refactor. So this iterative approach, red, green, refactor, that's what we're going to apply. And how does that work? Well, we have the server, 3 layers here, network, and then an interface to the services, my transaction scripts, and then the interface of the data access objects to the database. And we're going to use TDD around these 3, right? Because I want to implement my logic here, and that depends on the interfaces. So I need these, and I'm going to drive the functionality through the interface here. So this is the method. They're located here. Those are the ones called by the test. But we do have a problem because this interface is implemented by the data access objects, which interact with the database, and we don't want to depend on the database because that's going to add complexity. We might look at ways to sort of work around this, but if you work against a production database or the shared one for your group, then one group member might set up some data needed for test, and then another group member might delete it. And so it can be difficult to make sure the database is in the correct state before you start testing against it. So initially we don't want to depend on a database. We could later on make some integration tests which creates a clone of the actual database and sets it up with the exact data we need, and then work against that. I think that would be an interesting thing to see, so maybe we'll get there. But initially we are going to create a fake implementation of the interface. And we call that a mock, or a fake, or a stub, or a dummy. I'm not entirely sure of the differences, and that's not super important. The point is that we create a class that just stores tasks or whatever we're working with in a list or a map or something simple, so not the database. And that means we have control over the objects that we can store and retrieve. So we don't actually persist anything, but before each test we put in the data into my fake database that is needed for the test, and then we can retrieve that, work on it, and save it again, and then verify that whatever object is down here, whatever task is down here, actually has the updated data or not updated data if we are trying to make a failure test case. So that's the idea. All right, that's the transaction script theory and how we're going to implement it in the next video. So thank you for watching.